Now let's take these two problems here. What does the statement 1 here say? It says cos 80 minus sin 80 is negative. And statement 2 says cos square 25 degrees minus sin square 65 degrees is positive. Let's take the statements one by one. Statement 1 says cos 80 minus sin 80 is negative. Now we do not know the values of cos 80 and sin 80. So how do we figure out whether it is negative or positive? Cos of 80 can be written as sine of 90 minus 10, and in that case it will be, this will be cos of 90 minus 10. So this becomes sine of 10 degrees minus sine of 80 degrees. Now we know that as theta increases from 0 to 90 degrees, the sine theta changes from 0 to 1. So sine theta is an increasing function from 0 to 90 degrees. The smaller the angle, the smaller the value of sine theta would be, and the greater the angle, greater the value of sine theta is. For 0 degrees sine theta is 0, and for 90 degrees sine theta is 1. It is an increasing function. It goes on increasing from 0 to 1 between 0 to 90 degrees. So obviously sine 10 will be less than sine of 90 degrees, which also means that 80 degrees. So sine 10 minus sine of 80 degrees is going to be less than 0. Thus this is going to be less than 0, that is negative, which makes this statement true. Now what about statement 2? Statement 2 says cos square 25 degrees minus sine square 65 degrees. We do not know what the square value would be. So we can first convert it into the form a plus b into a minus b. Now both cos and sine are positive, so their sum is obviously going to be a positive number. What about this? Again, this we can change to sine of 90 minus 60. So this would be cos. So this cos 25 can be written as cos of 90 minus 65, which is 25, minus sine of 65 degrees. So this becomes sine 65 minus sine 65 degrees. So this would cancel out. These two are going to cancel out. Cos 25 becomes 90 minus 65. So this becomes cos of 90 minus 65, and minus sine 65 remains. Cos of 90 minus theta is sine theta. So sine theta minus sine theta is going to give you a 0. So this will become 0. It is neither positive nor negative. This is 0. Hence this statement is not true. It is false. So what is the option that specifies this? It says that statement 1 is true but statement 2 is false, and that option is option C. So you mark a C here. Now in this question, you take the first statement 1 and you simplify the LHS. LHS is equal to, you open up the brackets, you get here 3 cot square theta plus cot theta plus 9 cot theta plus 1 plus 3. So 3 and 3 cot square theta can be combined together and you get 3 cot square theta plus 1 plus a 10 cot theta. Cot square theta plus 1 is cosec square theta. So this is what you get, and this is equal to the right hand side. So this statement is true. And what does the statement 2 say? Statement 2 says cot square theta plus 1 is equal to cosec square theta, which is an identity. Hence it is true. And since we are using this identity in arriving at this, therefore we can say that statement 2 is the reason, is the explanation of statement 1. Statement 2 is used to prove statement 1. Hence the option that you will be marking here is the option A, which says both statement 1 and 2 are true, and statement 2 is the correct explanation of statement 1. So the option here would be A. Okay, now let's take this last problem from this type of problem, the assertion reason based problems. It says 2 cos theta is equal to a plus 1 by a, where a greater than 0 and a is not equal to 1. And the statement 2 says cos theta lies between minus 1 and 1 for all values of theta. Now, let's take the statement 1. It says cos theta. So you have 2 cos theta is equal to a plus 1 by a can be written as root a square plus 1 by root a square. Can it be written like this? Root a square will be a, so you can get the same thing. And this is of the form a square plus b square. So what is a square plus b square? It is a minus b whole square plus 2ab. Are these two same? This can be written as this and this can be written as this. Why? We have used what? A square plus b square is equal to a minus b whole square plus 2ab. We have used this relation here. A here is root a and b here is 1 by root a. Now this is a real number, right? A is greater than 0, that means a is a real number. So this real number square will always be greater than equal to 0. The square of a real number has to be greater than or equal to 0. And this would cancel out and you have plus 2. So what will be the value of this whole thing? This number is greater than equal to 0 and this is exactly equal to 0. So their sum is going to be greater than equal to 2. So we get 2 cos theta is greater than equal to 2. The 2 and 2 cancel out and what you are left with is cos theta greater than equal to 1. But we know that the value of cos theta lies between 0 and 1 for acute angles, and for angles lying between 90 to 180 it lies from minus 1 to 0. So the cos theta can never be, sin theta or cos theta can never be greater than 1. So cos theta is greater than equal to 1 is what you get here. Is it possible? No. It is not always possible. It is only possible, the only possible value here is cos theta is equal to 1. Cos theta greater than 1 is not possible. Hence, this statement is not true for these. So, if a statement is not true for any one condition, it is considered as false. So, statement 1 is considered as false. And this condition, this is always true. For any angle theta, the value of sine and cos always lie between minus 1 and 1. They would always lie between minus 1 and 1. So, this is true. This is true. So, the statement 1 is false, but statement 1 is true. The option that specifies this is the option D, which says statement 1 is false and statement 2 is true. So, you have to mark a D over here. There are a lot many questions related to trigonometric ratios and identities that are there in the book. You must go and visit all the problems that are given in the solved example section, and I would also request you to visit the exemplar problem section, which has been solved. The exemplar problems have been picked and solved in the book itself, so you must go through them, and there are some previous year questions as well, so you must attempt those questions, and I hope you will be getting a hang of what this chapter is. Now again, trigonometric ratios and identities is a chapter that requires a lot of practice. So if you don't practice, you might not be able to manipulate the identities and get the desired results. So one very important thing is to practice, and there are sufficient problems in the book. So I hope you practice all of them and get expert in this chapter.